So in this video we are going to simplify some of the circuits, and these are some of the circuit based on series and parallel combination and mixed combination, of course. There you can see there is no cell is connected. So whenever such type of circuit has been given, just you assume that across these terminals uh, the battery is to be connected. Okay, so such type of question will directly ask that find the equivalent resistance of the circuit across given terminals like A, B, or whatever they will give accordingly. So here once again just a quick summary. When resistors are in series combination, that is along a straight path, along a same path, then uh, their resultant is R equal to R1 plus R2 up to so on. And if they are parallel connection, in parallel connection, that is they get divided from same point and join to some other common point, then 1 by R equal to 1 by R1 plus 1 by R2 up to so on. If two resistors are connected in series, two or more resistors are connected in series, then their resultant get increased, and if they are connected in parallel, their resultant get reduced. So in order to get lesser resistance, we connect them in parallel. And also, as per our requirement, if we want uh, constant current through all the resistors, we connect them in series, because in series current remains same. And if we want constant potential difference, then we connect them in parallel. So there you have these question, have a look. All right, so we will start from first. I hope you have just make up your mind, and you can identify these circuits, but it is not that simple. If you think that and if you have identified it correctly, then well and good. Okay, then now I'm explaining it to you. So you can see here, in mathematics these type of lines are called parallel lines, but in physics parallel combination means when components have a common point from one end and common point to other end, then those components are called that they are in parallel combination. And series if path is same. So here in mathematics we can call these lines as parallel lines, but if we talk about the uh, resistors, they have been connected to a single path, and hence it is the case of series combination. So step 1, we'll mark the resistance R1, R2, R3, R4. Then we will write R1, R2, R3, R4 are in series. So R equal to R1 plus R2 plus R3 plus R4. Here and we can write the answer in its units. Then there is, we know that these are getting divided from a common point and they are meeting again at a common point. Some people might say that these two have a common point and these two have a common point, but see, actually if there is nothing else, just a wire, then this entire wire portion will be considered as a single point. So either we draw it like this or we draw it like this, both mean the same. So uh, directly we can say that first we'll mark R1, R2, R3, then R1, R2, R3 are in parallel. So 1 upon R, or we can say 1, 2, 3, the combination of all of them is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. I'm directly putting the values. This is not the answer. Now we have to reciprocate this. So R123 is equal to 2 by 3 ohm. Next, here it is getting divided from here and combining at here, but these two are not parallel, these two are not parallel. Both are in series, then their series. One R2 are in series. Solve that bracket based questions. So one by one we go to solve, simplify that. So in the same way, R1, R2 are in series. So R12 is equal to R1 plus R2, that is 9 ohm. And then R12 and R3 are in parallel. Okay, so 1 upon R is equal to 1 upon 6 plus 1 upon 9. So it is 18, 3 plus 2. So here it is R equal to 8 upon 5. We can simplify it into decimals. You can do it of your own. Here also, this is R1, this is R2, this is R3. So first we will solve this, simplify this. R2 and R3 are in parallel. So 1 by R2, 3 is equal to 1 by 4 plus 1 by 4. That is 2 by 4. And that is 4 by 2. That is 2. We have to reciprocate. So we have to take reciprocal of the final which comes, because it is 1 upon R. So that is why. And now this R23 and this R1 are in series. So R1 and R23 are in series. So R is equal to sum of both, 2 plus 2, that is 4 ohm. So till now these circuits were quite easy to solve, and only we need to find we need to just simplify the circuit. But there are some questions in which further different question also asked, like current in the circuit or potential difference across any of the component. So in such type of questions, I'm taking two examples of such type of questions. So this is the first type of question. It is quite obvious that all these three are in parallel, and they are in series with this one. 30 volt, 5 ohm, 2 ohm, 3 ohm, 6 ohm. So let us suppose this is the question. So the question is, actually they are asking us first find equivalent resistance, and then maybe they can ask uh, current through 5 ohm and 2 ohm. Okay, or they can directly ask find current through 5 ohm or 2 ohm or whatever. They can also ask to find potential difference across any of the component. Let me remind you, this 30 volt is not solely given to this 5 or this 2 or this 3 or this 6. Potential difference get divided among the components. So some of this 30 volt has been given to this 5 ohm and rest to this entire parallel combination. However, whatever with the potential difference across this will be the same across this, will be the same across this, and will be the same across entire this combination. All right, so now step 1. Okay, whatever be they are asking, just remember one thing, whatever be they are asking, you need to do just the one thing. You need to first simplify the circuit, first solve it, and that's all. So this is what we are going to do. R1, R2, R3, R4. R2, R3, R4 are in parallel combination. So R2, R3, R4 are in parallel combination. So 1 upon R234 is equal to 1 upon R2, R3 and R4. That is, that's amazing. 6 by 6, that is 1. But be very, very careful. Don't put ohm here. R234. Take the reciprocal of this. Now, entire this is equal to R234, and that is 1 ohm. Next step, R234 and R1 are in series. R1 and R234 are in series. So R is equal to, or R1234 is equal to R1 plus R234. That is 5 plus 1, 6 ohm. Find current. Try to find current throughout the circuit. So E by R. How is it so? Because V equal to IR. This is the total current. I1, 2, 3, 4. V1 to pass through ohm. We know that potential current is same in series combination. So also here current will be the same. So we can write that this is equal to I1. What is I1? Current through R1, because current is same in series. Actually, current remains same in series. All right, so first this part we have done. So current through 5 ohm is 5 ampere. This entire current will go through R1, but remember, the same current is not going through R2 or R3 or R4, but this 5 ampere will get divided among them. So how to solve this question in this case? So here what we can do, we can find potential difference across this combination V1, 2, 3, sorry, V234. We can find this. What is the advantage for that? I will explain you later. V equal to IR, I123, sorry, 234 and R234. So I234 is same as this I1. I234 means through entire this combination. Oh my god, entire this combination. This is I1, this is I123. The same is going through R1, then I'm calling it I1, and the same is going through the combination of them. I'm calling it I234, and that will be the same, 5 ampere. And resistance 234 is 6. Sorry, 234 is 1. Otherwise it was illogical. So here it is 5 volt. So V234 is 5 volt. And now we know that potential difference remains same. So V2 is equal to V3 is equal to V4, and which is equal to V234, because potential difference is same. In parallel. That's all. And now we are interested in this 2 ohm part. So I2, because we marked it as 2, is equal to V2 by R2. V2 is 5 volt, R2 is 2 ohm, so it is 2.5 ampere. So ultimately, if we want to find current through any component, first we need the potential difference across it, and if we want to find potential difference across it, we need current through it. So in this question, the basic idea was that are we able to apply that concept that in series combination current remains same, or in parallel combination potential difference remains same? Are we able to apply that concept or not? So next video I will explain some more complicated problems.